Good afternoon, everyone. We'll get started momentarily. Okay, thanks, everyone. I think we'll get started. Thanks for attending the April 2024 edition of Green Infrastructure, Climate, and Cities. My name is Franco Montalto. I, along with other folks from CC Run, the Consortium for Climate Risks in the Urban Northeast, I'm happy to welcome you. Happy Earth Month. And if you're joining us for the first time, just to let you know, CC Run has been hosting this series back since 2014. We recently updated our website, and you can see most of our previous webinars on the CC Run website. All of our seminars have been livecast, recorded, and they're archived. Professional engineers can get continuing education credits for attending. And we look forward to your interactions with today's speaker. So if we go to the next slide, I'd like to introduce our speaker, Mr. Glenn Hurricane Schwartz, who is a recently retired chief meteorologist for NBC 10 in Philadelphia, with 50 years of professional experience in weather forecasting for entities including the National Weather Service, the National Hurricane Center, the Weather Channel. Glenn has become one of the best known and respected meteorologists in Philadelphia TV history. He has also written and spoken about climate change for over 20 years. And in fact, that's how we met. I was at a conference on resilience in Philadelphia, and the keynote speaker was Glenn, whose presentation was really inspirational. Currently, Glenn serves as a senior consultant for climate change and resiliency for the consulting firm AKRF. So thanks, Glenn, for joining us. We're looking forward to your presentation, which is entitled Climate Crisis, The Old Rules No Longer Apply. And just as a reminder, please do not use the chat to submit questions. While Glenn is speaking, you can submit any of your questions in the Q&A box, and Glenn will talk for about 45 minutes or so. And then after that, we'll move into a questions and answer session. So feel free to submit the questions as Glenn is speaking, and I will pose them to him at the end of his talk. So with that, I'll hand things off to Glenn. Thanks so much for joining us.
All right. Thank you very much, Franco. And I want to make sure that I have this full screen here. Before I get to the meat of the subject, I've got a picture up there. I wonder if some of the folks can identify it. It's obviously an old picture, but it's also an important picture because today is an important day in weather history. And April 3rd, 1974, 50 years ago, the worst tornado outbreak in history by far nearly 150 tornadoes in one day. This one, it was Xenia, Ohio, near 5, killed 32 people, and it really got a lot of attention, and it was never matched until about the beginning.
You can start again. We
Yeah,
heard the first slide, but then you froze.
yeah. Okay. Well, this is again is the picture of uh, the EF5 tornado in Xenia, Ohio, part of the biggest tornado outbreak in history. And today is the 50th anniversary of it. And it was a remarkable day. And we're going to talk more about tornadoes a little bit later. We also are going to talk about all the effects and impacts that climate change is having, especially in this part of the country. And the main problem, the biggest, most dangerous in this part of the country is flooding. We have issues at the coast and we have issues inland. The Schuylkill River in Philadelphia represents some of the worst flooding we've seen. And then, of course, at the Jersey Shore, Wildwood, and Ocean City, examples of coastal flooding. Different types of flooding, somewhat related, but also unique in other ways. And the reason I'm concentrating on flooding here is because of all of these pictures. These are scenes from countries all over the world of disastrous, record-breaking, unprecedented flooding. Here's another screen full of different countries, practically every continent in the world represented. Here's the United States. We had an incident in Bucks County last year where a child was drowned. Every one of those pictures that I just showed you happened in 2023. Every single one. And when I show this composite to various groups of people, they just can't believe that it all happened in 1 year. Now, we didn't have a whole lot of video and worldwide attention years ago, but we still have never seen a year like 2023. And that is kind of scary for multiple reasons, as you'll see. But we talk and we hear about people saying this is the new normal. All this extreme weather and these record warm temperatures. This is not the new normal. It's the new normal for today. Because the climate keeps changing, it's just the new normal for now. You can't just assume that this climate is going to be the same even a couple of years from now because it's changing so much. Now, I go back a long way, and this picture shows it. That's me on the right. And that is in 1972, right there, in State College. This was the firm before it even got called AccuWeather. This was AccuWeather. The guy on the left was the president, Joel Myers, guy in the center, Elliot Abrams, who became famous on KYW radio years later. So I was obviously a fashion icon from the very beginning. That is supposed to be a joke. That's 1973, that picture. So I go back a long ways. And I also go back a long ways specializing in severe weather. And when I went to the National Weather Service, I had the title, it was called Disaster Preparedness Meteorologist. And these guys that are in the picture with me, and again, I'm on the left, that is emergency management in Georgia. And I wrote scenarios for severe weather and hurricanes so that they could go through their exercises to see how prepared they were in the state. So I've been involved with severe weather a long, long time. I was also the first storm chaser for the Weather Channel. That is how I ended up with the nickname that you see on the screen. I didn't give it to myself. There was no meeting or focus group or a discussion that decided on, well, we're going to call this guy Hurricane. It just happened. And we had never set foot outside the Weather Channel office in the first couple of years. And I managed to talk them into letting me go out and report on it, since it is TV and TV is about pictures. And from there, now they send 20 people out chasing snow flurries. But that's how it started. And my interest in climate goes way back 27 years ago when I started off at NBC 10 in Philadelphia. I was uncertain about any connection in climate. 17 years ago, I became suspicious about the connection. And 7 years ago, became certain. These are some of my coworkers over that time. And the science is certain. This is as certain as gravity. There's just no debate among climate scientists. There has never really been. This science has been around for actually a couple hundred years. We know that carbon dioxide and temperature go up together. As CO2 rises, so does the global temperature. And it was very obvious to anybody 30 years ago. And one of the ways that we prove that is by making weather forecasts. And that line that you see in the middle over here, that is the time at the year 2000 that this particular forecast started. And the forecast line you can see in the black, that's the mean. And then the red is the actual. Now, up at the top and the bottom here, those are within what they call the ensemble spread. So 95% of the solutions as you run these computer models are in that zone. So as long as you're in that zone, the forecast is considered accurate. Another way to test it is to go back in time. We call a hindcast. So you go back to 1970, put your equations there into the computer and let it project into the future. And lo and behold, it's almost a perfect fit. There's just no question that the forecasting has been accurate. The science has told us what is likely to happen, and the computer models have a really good handle on it. And this, again, goes back to 1970. And again, you can see the ensemble mean and also the spread there and possibilities. Now you see a couple spikes there, and this is a close-up of that. That first spike, this is in 2016. That was in a super El Nino year, and we're almost out of the purple, but we're not quite. And then this is 2023. A spike up, but we're still within the 95%. So technically speaking, the forecast is still on track, but we need this to drop dramatically, just like it did in 2016, in order to feel comfortable about that. Now, one guy who's not comfortable about that is James Hansen. He's been around for a long, long time, testifying here in front of Congress in the 1980s, first talking about the connection between climate and warming and the effects of it and the problems that is going to occur. And he was right. And so he was the head of the climate division in NASA, and he is a very well-respected scientist. So what he has been saying gets people's attention. And he wrote a paper just last year talking about the warming is accelerating. It's called global warming in the pipeline. You might want to look that up if you're interested. And what he has shown in his study is his belief that the warming is accelerating. This is where it would be if it was continuing on its current path. But that acceleration is a real concern to him and anybody who agrees with him. This is one of the people who's very concerned. And even though James Hansen is considered kind of an extreme thought person about this guy isn't. This guy's the director of the NASA Global Information System, and he's been around for a long time, very well respected. Started the group online decades ago, and his quote in the article just a couple of weeks ago: climate models can't explain 2023's huge heat anomaly, and we could be in uncharted territory. That got my attention even more than James Hansen himself. But not everybody agrees with this. My point on this is that 2024 will help decide who is right about this. Is Hansen right about the acceleration? Or are people like Michael Mann, who is saying that we're still going up as predicted, which is bad enough, which is going to be right? This is one of the graphics that I've seen, again, of concern. The absorbed solar radiation is increased more than the outgoing. What does that mean? That means there's more heat building up on the Earth. I wrote a blog about that. You can see on my website, thehurricaneschwartz.com, if you want to take a look at that in detail. But this is a critical year, and one of the reasons you can tell that is in the oceans. The oceans may be even more concerning than the changes in the atmosphere. It's just going off the charts. They have to change the scale on some of these charts because it's just so amazing. All of these lines in here, these are all the previous years going back. And that 2023 was way above records. And here we are in 2024, smashing the 2023 records. Now, the El Nino that has helped cause this is changing rapidly and going into the opposite, the El Nino of a La Nina. And this should lead to cooling of the oceans and of the atmosphere, especially later in 2024. And it better happen, or else James Hansen is going to be absolutely right. Now, why would this be happening? There's a disagreement on this too. Now, there's no disagreement on the basic science. Carbon dioxide leads to increased temperatures, which then leads to other problems. One of the reasons that the Earth didn't warm a lot between 1940 and 1970 was all the pollution. And those of you who are old enough remember how polluted a lot of our cities were, even in Philadelphia, just terrible. The river in Cleveland would catch on fire, and this was worldwide. And they changed the rules. There was a Clean Air Act in 1970, and that cleaned up the atmosphere. But what that also did is it allowed more of the sun's rays to get through. And that allowed the warming to accelerate. But at the same time, the shipping in this zone that you see here in the red, the Pacific and the Atlantic, that's the main shipping channel. And you can see it goes right over the United States and over the other most populated parts of the Earth. Well, they hadn't changed the pollution rules there. And so some of that pollution, the sulfur dioxide, blocked the sun's rays and caused less sunshine to come through in those areas. And what's the result? Well, here's a recent paper showing globally absorbed solar radiation. That is not encouraging. If you have more radiation reaching Earth, that means the warming is going to accelerate. And so is this the sign that this has already happened? Here's that same graphic along with the decrease in the sulfur dioxide in shipping. Probably not a coincidence, happened at the same time. So as we reduce the sulfur dioxide, this is this is the catch 22 here. We get rid of pollution, that causes more of the warming of the earth. So by doing something good that we know is good, it's creating something bad. And one of the other things that's happening that's bad are the increase in natural disasters. Now, some of this is happening faster than the computer models had suggested decades ago. Their basic forecasts are fine, but some things are happening way faster than a lot of climate scientists thought. The natural disasters around the world and also the sea level rise. And the most extreme weather is increasing faster than predicted. Here's the sea level rising. Here's a 10-year period where it went up. This is global, about 3 millimeters per year. And the next 10 years, that's quite an acceleration over a 10-year period. This also leads to more flooding. So we'll get into the sea level itself a little bit later, but just with the warming, you're going to get more flooding. You have warmer air, a warmer ocean, you have urbanization, you have stronger storms, you have slower moving storms. That's the inland flooding and the reasoning for that increasing. Coastal flooding, you have the general sea level rise, you have subsidence on the land, especially on the East Coast of the United States, which doesn't do us any good. We have stronger storms, melting glaciers, and ice melt from mainly Greenland and Antarctica. And the reason that we know the reason for the increase in flooding is that when you warm up the air, you get more rain. It's a basic equation in physics. There is no dispute on this. For every 1 degree increase in temperature Fahrenheit, there's 4% more water vapor in the earth. Well, 4% doesn't seem like much, but the thing is, it's not a uniform increase. You get the giant increase within the storms and also near the warm ocean. The moisture gets concentrated in small areas. And as the extra moisture evaporates, it causes even more warming. So this is known as a threat multiplier. And so everything gets worse at an accelerated rate. So that means you get the increase in the heaviest precipitation events, not just the total rainfall for the year. That's not as important. It's the isolated events, the extreme events. Those are the ones that kill people. Those are the ones that knock down houses. Those are the ones that lead to the coastal flooding. And here we are in the Northeast United States with the biggest increase of downpours. Extra moisture evaporates, causes even more warming. And here's another slide showing that. It's not just getting wetter, the wettest days get wetter. And that looks like it's accelerating also. So these are, again, increasing concerns. We know that we're headed in this direction, more warming, more moisture, but it's this acceleration possibility that's the most recent and most important concern right now. So a lot of the moisture occurs in what we call atmospheric rivers. This is a moisture satellite picture. This is the west coast of the United States, and there's Japan. So this is the entire Pacific Ocean, and here's this atmospheric river of moisture, basically across the entire Pacific. And you've heard about all these atmospheric river flood events in California. We've had them this winter. But we also have atmospheric rivers in the east. This is one that helped produce flooding all up and down the East Coast. This is less frequent, but It causes a lot of floods, and climate change may be making them worse. Here's Philadelphia itself, the #3 city in the entire US in the increase in heavy downpours. And as evidence, since 2010, in Philadelphia, the wettest hour, the wettest day, the wettest month, the wettest year. All records, and some of those records, not just broken, but smashed. Here's an example of the kind of extremes that have been happening. Here we have Brandywine Creek, which tends to flood in Philadelphia. Flood stage is 9 feet. Major flood stage is 13 feet. The record was 17 feet. So what are you going to do? You're going to prepare for a potential record flood stage. It's 17 feet, right? Well, in 2021, we had Hurricane Ida that produced a new record of 21 feet, 23% above the all-time record. So you're not planning for a record flood over to 17. Now we have to plan for records 15 to 25% above the previous records. And if you're not prepared for that, you're going to be unpleasantly surprised. So let's say 20 years from now, what are you going to plan for in Philadelphia? We'll go back 125 years. The record for one day in Philadelphia was 5.63. Normally, we break records just by small amounts, less than 10%. But we had Hurricane Floyd in 1999, 6.63. That's an increase of 18%. So what do we prepare for 6.63 or a little more? Well, we better prepare for more than that, because in 2013, we had 8 inches in one day. That's another 21% increase. So, okay, now we'll prepare for 8 inches. Well, that may not be enough either, because in Ida, Flemington, New Jersey, not far away, had 11 inches of rain in one day. And if Flemington can get it, Philadelphia can get it. It's just a matter of the bad luck. That's another increase of 37%. So we're not really prepared. And too many planners and governments and businesses are not planning for enough of a flood threat that we are going to have, not just today, but of course it's going to get worse in the future. It's existing NOAA estimate of a 100-year flood in Philly is 2.9 inches an hour. The problem is that's based on data that's 20 years old. Government hasn't gotten around to updating this yet. And you see the darkest area on the map right over us is the area with the biggest underestimate. And so this nonprofit organization called First Street suggests 4.8 inches should be used, 65% higher in the current climate. Now that study and that company, it's a little bit controversial, but it's given you the idea of just how old and worthless the data is that a lot of people and businesses and governments are planning for until this data gets updated. And the biggest problems are in our part of the country. So again, we can't just assume that these rain and flood records are going to be broken by slight amounts. 15 to 25% would be my estimate. And when we talk about 100-year floods, that can now happen every 16 years if First Street is right. And in places like Berks County, every 11 years. You keep hearing about, well, we had another 1 in a 100-year flood, another 100-year flood. Why does that keep happening? Because it's not really a 100-year flood. We're not using the right data. Sea level rise in Philadelphia, of course, that's increasing. So it means the same storm produces more of a flood. And in other parts of the country, there's Pensacola on the right. That's accelerating significantly. That's 6 times the level that it was between 1923 and 2009. Why has this happened? And these projections for sea level are way off. And we're way underestimating this. And why are we underestimating this? partly because there's melting, severe melting in places like Greenland and Antarctica. And this is a study in nature, Greenland melting at some of the fastest rates in 12,000 years. Look at that ice melt. And compared to, that's the average over the years. And these lighter grays are the individual years. Just smashing records. And not just there in Antarctica. These are temperatures historically, 1990 to 2022. And here we are. There's a day so far above the all-time record, 69 degrees above normal. So if we were 69 degrees above normal in October in Philadelphia, it would be 137 degrees. That's how freakish this is. And that melts ice. You melt ice, you get rising sea level, you get warmer temperatures because the reflection with the sunshine over the dark ocean versus the ice. And the projections. So here we are in the Philadelphia, and we get just a couple of floods a year. But projections, another 50 years, it could be flooding every single day. And not just Philadelphia. And so we can't even say that particular storms cannot be blamed on the changing climate. We used to be able to say that. We used to say that. But that's one of the things that's changed over recent years, because we now have this part of the science called attribution science. And you could look up and find out more on worldweatherattribution.org. For example, Sandy's 2012 had 60 billion in damage. They estimate that 8 billion of that occurred because of the sea level that had already occurred. That's one example. The deadly heat wave in the Pacific Northwest made 150 times more likely because of climate change. So they become more likely and more damaging. Now I just added these slides a couple days ago because this started reminding me about this tornado issue. The National Academy of Science put out this graphic, very nice graphic of the confidence in the attribution of specific events to climate change. The close-up here shows that on the upper right, the temperature, the heat, and the lack of cold we're the most sure about, and there's the most evidence about. Next is droughts and extreme rainfall. But if you look down at the bottom, the one with the least confidence is severe convective storms. The least amount of confidence. So we're not talking about more tornadoes. We're talking about the tornado outbreaks being more severe, like the one that happened in 74. And look what's happened to tornadoes since 1979. Tornado Alley is no longer in the plains. We used to think it was up here. Now, there it is. That's the increase in the number of tornadoes per decade. Now, this is a more dense population, and that's one of the factors that makes this more dangerous. This is the worst tornado outbreak ever in April 2011. 360 tornadoes in a couple of days, as you see the tracks there. None of them in Tornado Alley, what used to be called Tornado Alley. And look at the worst 5 tornado outbreaks. 4 of the 5 occurred since 2010. Remember the rainfall records in Philadelphia since 2010. And maybe that's not a coincidence. Not that we're getting more tornadoes or hurricanes, but we're getting, when we get the conditions that are right, it becomes more extreme, more dangerous, more destructive. And there's the hurricanes, just since 2017, rapid intensification. And this is becoming more and more clear that we're seeing a greater percentage of hurricanes undergoing rapid intensification. And then when they hit the US, horrible things happen. And you could see all over the Gulf states and Florida in less than 10 years. And the graphic on the left, happening more in a warming world. That's what's supposed to happen. We have the warm oceans. Now, in the Delaware Valley, in our general area, we have different flood types. And these four pictures represent those four. And we're going back into the mid 50s in Easton, Harrisburg, then Bloomsburg, Philadelphia. In 55, it was back-to-back hurricanes, 1 week apart. In 72, it was a tropical storm that stalled, Agnes. In 2021, we call them training of storms. They just keep going right over the same zone. And then the other possibility is a hurricane track just to the west of Delaware Bay, and that piles the water right up Delaware Bay and into the Delaware River, and that has never happened. Of course, it could. Sandy came fairly close to that kind of track. So here's your back-to-back storms, 2 hurricanes in less than a week. Hurricanes more likely to strike twice, may drive more hurricanes toward the East Coast. Again, these are recent studies. That's a year ago. Hurricane Agnes, because of stalling, 19 inches of rain for the max. But that was before 50 years of warming, a much warmer ocean, a higher population, and more runoff. So another Agnes would be way worse than the original one. The storm training, imagine Ida with even more rain after years of warming and a warmer ocean and higher population and more runoff. Lower right, that's what happened in New York City. They had it even worse than we did in Philadelphia and in South Jersey. And here's your track. This white line, that is Sandy. But if Sandy had come up this way, that flooding, that storm surge would have come right up Delaware Bay. And with the narrowing of that area, that is a worst case for Delaware and Philadelphia. We've never seen it. It's just a matter of time till it happens. So there's increasing evidence that our area will experience worse floods, more extreme hurricanes, much worse coastal flooding with sea level rise, more frequent floods, the record's broken, and places that have never flooded before. If anybody's had a close call, it's going to flood someday. But we also have the technology to slow and even stop this warming. If we did it, if we stop putting the extra carbon dioxide and other greenhouse gases into the atmosphere, the temperatures would start to level off. So we know what's likely to happen. We know what the threats are. And it will cost more for us to do nothing. We have to be more resilient. We have to adapt to these changes that are coming because there is no planet B. We have no other choice. We do have the power to make some of these changes. These are books that are, of course, much more optimistic than some of the others that have been out there. But there are climate optimists that we can do this. We just need the will to do it and global cooperation too. But what if, oh, it just got a crash of thunder? What if it's a big hoax and we create a better world for nothing? That's the bottom line. We've got to create the better world because we have no planet B. We have no other choice. We know how to do it, and now we need to do it. Thank you.
Thanks so much, Glenn. That was great. And we have a number of questions. I invite folks to add your questions. We have plenty of time for discussion. As we get into the Q&A, I just wonder if you mentioned back 25 years ago you were uncertain, and I'm just curious, the transition from uncertainty to certainty. What were the key sort of data points in that transition? What were the? I wonder if you could just talk about what you saw in that 25 years of weather
Sure.
that sort of
Well,
changed here.
yeah. Well, I heard about global warming back when I was with the National Weather Service in the 1970s. There were some popular magazines and uh, news stories about the cooling climate, talking about ice age, But within the science of meteorology and climatology, the threat was always looked upon as warming. Okay, so we're cooling temporarily in the 70s, but we had a lecture from the head of the climate center, and he said, don't talk about the cooling. But by the year 2000, warming is going to be the issue, and that's the issue of our future. So that started me wondering about it as I saw different records being set in the 90s and early part of the century. But it was when we started hearing a controversy about whether it was indeed warming or not. And you heard some stories about, well, satellites are better at doing this. And so the satellites measuring or estimating the temperature of the Earth, they're more accurate and they're not showing warming. So now we had a debate that was in the 90s, mid 90s or so. But it turned out that the satellite people were wrong. They had bad data that they put in. And as soon as we found out that their whole method was wrong, that's when I started accepting the fact that it was in the other direction, that it was the ground observations that were correct and the satellite observations that were not. And that's pretty much the way it's turned out.
Very, very interesting. Just for those who might be on the call who are involved in research, just sort of like the role of data accuracy in informing opinions and so much more. The first question we had from Edward was just looking for clarification. You mentioned some of Michael Mann's recent work, and Edward is asking if anyone has compared sea surface temperature just during the last major El Niños to see if the level of variation that we've had recently, how much more is it than previous El Niños?
Yeah. We did have an increase in 2016, for example, but now it's above that. Now it should be because, again, the basic scale continues to go up. So we again want to see what happens with the rest of this year. Does that ocean temperature start to come back closer to normal? If that is the case, then Michael Mann is looking more and more right. If we continue to see these astronomical ocean temperatures through the rest of the year, and maybe even into next year, then we'll be more concerned with James Hansen being right on that. It's not a huge debate because everybody agrees it's going in a certain direction. It's just how fast is it going in that direction?
Right. And you talked about the relationship between air pollution and temperature and warming. And of course, there is out there discussions about geoengineering, putting particles up in the air to intercept some of the incoming solar radiation. And Carl is asking, I mean, the way he puts it is maybe we quote unquote need a little pollution, but I wonder just if you want to
Yeah.
sort of say something about your opinions on geoengineering and that whole debate.
Well, um, I am very scared about the possibility of that happening. And I think it's a terrible idea to uh, think that we may be in a position to do that, and that gives people a reason to not make changes, to not see the immediacy of this. And oh, well, if we get into trouble, we'll just put a whole bunch of stuff up in the atmosphere and block the sunshine. And well, first of all, that would require a worldwide effort. Okay. Are we going to get cooperation from Russia and China if we start throwing stuff up in the atmosphere? Maybe Russia doesn't want it to cool down. Maybe they're fine with the warming because they want the Arctic to melt so they can drill for oil and use those waters. So now we're not we're not in charge of the world, number one. Number two, we don't know what the effects are going to be, the side effects. Here we were cleaning up the atmosphere in 1970 and ending up with more warming. Didn't see that coming. What else are we not seeing coming? So we, like I said, we only have one planet B. We can't be making and doing experiments in our only atmosphere. I'm just dead set against it. And I think a lot of money is being wasted in thinking about it and researching it. And we need to put the money into renewable energy and cutting as much of the greenhouse gases as possible and focus on that.
Great. And there was someone asking for a clarification. You mentioned Philadelphia is, what is the ranking in terms of heavy downpours and wetness?
Yeah.
You want to give me a little bit more detail there?
Yeah. It's the rate of increase. So that slide showed a 360% increase in downpours over a certain period of time. So on the list of cities with the greatest percentages of increase, Philadelphia was number 3.
Got it. And I mean, this is a question that I had as well, although Lisa's asking a question about the 100-year flood. I mean, you made this really interesting point that it's not the new normal, because that would suggest that it's stationary, that it's uniform, that it's going to be like this for a while, and
Right.
we're in more of a dynamic situation where things are changing continuously. So what does that mean about, something like the term 100-year flood? I mean, we have these statistical approaches that we use to analyze a certain period of data. We compute the frequency, and then we call it something. And then we don't get around to redoing it for a while. Although I know some people have advocated, a more regular updating of a 100-year storm, a 100-year storm for the next 5 years, and then we redo it and we redo it and we redo it. But what are your
Right.
thoughts on sort of
Right.
how the statistics, what is the appropriate way to be talking about these events in this sort of dynamic context?
Well, I think that to a lot of us meteorologists, we wish the term 100-year flood or 500-year flood, 1,000-year flood had never started because it is so misleading. So people think that if it's a 100-year flood, if you had the flood last year, now you got to wait 99 years for it to happen again. And that's not what that means. It means there's a 0.01%, a 1% chance in any given year of a flood of that level. And that's in a stable climate. We don't have a stable climate. So that makes it obsolete too. We have 20-year-old data we're working with. That makes it obsolete. So between being obsolete and misunderstood, it's a terrible term. And I wish it would be totally wiped out, and we would just say we have this percent chance of, let's say in the Brandywine Creek, of a 20-foot level in any given year. And 10 years from now, instead of being a 2% chance, maybe it'll be a 4% chance. And I think people can understand those things a little better than the 1 in 100 year or 1 in 500 year.
But I also heard you saying something about how, in observing the rate at which records were being superseded, that there was a certain percentage, I think you said 15 to 25%, if I'm not mistaken,
Yeah.
Increase each time. Is there a way of characterizing the rate of change of an event so that instead of doing this kind of probabilistic analysis that you think is credible? In other words, looking at the rate at which certain thresholds are changed over time and then projecting at least, a rate.
Yeah, well, what I was doing was looking back and seeing how much records were being broken by. And that's how I came up with that general amount. That may vary in different parts of the country. That First Street study was even more extreme than that. But we're not talking about precision science here. This is based on estimates, it's based on averages, it's based on computer projections. I'm just trying to help communicate the general idea that you can't just plan for a record-breaking event, especially if you're trying to plan 10, 20 years or more into the future. You got to plan for much higher level because we've been breaking records by those amounts or even more, and trying to call people's attention to that. Now, if you plan for 50% above the all-time record, then maybe it's going to cost too much money to do that. So that's up to the individual businesses or communities to decide what level they need to go to. But you can't just go to the existing record and say we got to prepare for that.
No, it's interesting because on the one hand, the historical records are not necessarily representative of what's happening now. On the other hand, I think, and correct me if I'm wrong, meteorologists are getting more and more accurate with their short-term forecasts. And I wonder, how do you put those two things together? I mean, if the tools that are used by meteorologists to understand what's happening in the near future or like the next few days are getting better, can those same tools not be used to look at longer term trends to sort of, I wonder if you could just talk a little bit about that, the difference between climate and weather, that kind of thing.
Yeah. Well, first of all, with climate, we're not talking about what the temperature will be on April 3rd, 2050.
Uh-oh. Hoping Glenn didn't, Glenn, are you back?
I don't know.
Okay, you're back. Yes.
Okay.
But you didn't hear what you
okay.
said, so you should start again.
Okay. So when we're talking about climate, we're not talking about what the temperature will be on April 3rd, 2056. We're talking about a possible range of temperatures during that decade. So we can't get specific. That science just isn't there. That's like when I see on TV a forecast for the rainfall over the next 3 days. Let's say it's 2.37 in Philadelphia. Well, we don't have the ability to get that specific. So I always hated to do anything that was more specific than the science allowed for. And that was in daily forecasting. To do that for climate is even more ridiculous. So yeah, we're better at forecasting than we used to be. But hey, I was watching the news 2 days ago, and there was a forecast out of the computer of over 4 inches of rain in parts of Delaware and South Jersey in this week. And then last night, I see forecasts that are now more like an inch and a half on average. That's a tremendous difference over just a couple of days. And we're not talking 20 years from now, 50 years from now. We can't even be that precise about 2 days from now.
So, I know you pointed out that how lucky we were that Sandy didn't sort of go straight up the Delaware estuary. And it just struck me when you were talking about that, how important sort of these really local differences are in determining the outcomes. And I know there's a sort of large discussion about, if you infer trends from weather stations that are, one here, one there, you're often missing some of the local phenomena, right? Because you can't have a weather station everywhere. And I'm seeing a question from Michael who's asking about what the best sources of data are. I mean, and I know I've been involved in some studies where we looked at just sort of newspaper reports, just of what happened to sort of better understand floods than then the understanding you would have just looking at sort of like the Philadelphia airport gauge, for example.
Right.
But I'm wondering sort of like multiple sets of data, what do you trust, what are the to really get the sort of regional perspective? Do you work mostly with radar? Do you work mostly with weather stations or sort of anecdotal or reports from the field, with people talking about what happened in a particular place?
Yeah. I try to look at studies that have been done on this, detailed studies. The Northeast Regional Climate Center, I believe Cornell runs that, is really good when it comes to detailed stats about things like rainfall over the years. You just can't take the one spot. I mean, I showed Philadelphia numbers as just an example, but as an example, using Philadelphia with Ida, we have 8 inches of rain, but in Flemington, New Jersey, not that far away, it was 11 inches. So we have to assume that the highest amount was not in that one particular place where there happens to be a gauge. So if Philadelphia had 8 inches, you look back in the records for Ida, and you're just looking at the Philadelphia airport, you say, oh, we had 8 inches of rain. Well, some parts of the area had 4, and some areas had close to 12. We have to really get into the details. And some places like the Northeast Regional Climate Center, there are some private businesses that do specific research for businesses and communities to break it down. They're private meteorologists who do that for a living.
But would you say that it's likely that any kind of a trends analysis that's done on a gauge basis is probably underestimating? Things are probably changing faster than that.
Well, it's as likely to underestimate as overestimate. So I don't think we can assume that that it's going to be in one direction versus the other. We just have to assume that that one particular spot did not get the greatest amount of snow, even though in the blizzard of 96, it sure seems like Philadelphia International had the most snow of any spot within 100 miles. That seemed a little strange at the time and would rarely happen.
So there's a question here about Antarctic ice loss, and unfortunately there's an acronym that I'm not familiar with, but maybe you are. the AMOC slowdown or the AMOC slowdown and
Right,
catastrophic Antarctic ice loss. Do you have any sort of opinions about or thoughts or evidence on what
right.
what's
Well,
happening there?
yeah, the AMOC, the Atlantic Meridional Overturning Circulation, I believe it's called. Um, there is some people called it like a ocean conveyor belt where water in deep levels travels from South America or the southern Atlantic all the way into the North Atlantic and then sinks near Greenland and then comes back. It's just this whole oceanic circulation. And it's it's very interesting that the movie The Day After Tomorrow illustrated that it sped it up to ridiculous levels, like it was happening by the hour, where in reality it would maybe happen over decades, even if that was considered rapid. But that is slowing down. There is evidence of it slowing down, which does a few things. It might end up preventing Europe from warming as much of the rest of the world. It could eventually end up leading to cooling in the Northeast United States. So if that Gulf Stream, if that warm water is being blocked or slowing down, the reason England is so warm, it's pretty far north. It's because of this ocean circulation. And if that ocean circulation slows down or stops, you're going to have some pretty dramatic changes. Now, that's not going to happen worldwide, and it may eventually be overcome by the total warming. But we could conceivably see periods of even a couple decades of extreme cold in places like Europe and maybe even the Northeast US. And the other thing that it does, as it slows down, it's increasing sea level along the East Coast of the United States. The sea level in this part of the world is increasing faster than just about anywhere else in the world, partly because of the slowdown of this circulation.
So, we have two questions about what to do, right? So Lisa's asking the current 100-year flood, like what we call a 100-year flood, which, as you mentioned, has a 1% chance of occurring in every given year. Lisa's asking, so what is the actual percent chance that you think we could get what has historically been a 100-year flood right now? Is there a way to kind of sort of escalate the historical frequencies to get something that's more representative of where we are right now?
Yeah, well, that's what First Street has tried to do. And again, there are some questions about their methodology, some disagreements about that. But as I was showing in that one slide, instead of a 1 in 100 years, it's more like once in 16 years in and around the Philadelphia area, and 1 in 11 years in Berks County. So they break it down county by county. Now, again, we're talking about getting maybe more specific than the science would allow and giving you a kind of a false sense of accuracy. But that's one of the few attempts that I've seen to get into what the real probabilities would be, rather than using 20-year-old data, which shouldn't be used at all. I would rather, let's say, ask a professional meteorologist for his opinion rather than use a 20-year-old data.
Yeah.
That's just ridiculous.
So what is this, based on that, what does this tell us about the utility of, say, the FEMA flood maps? And, because the FEMA flood maps show us 100-year 100-year floodplains and 500-year floodplains associated with specific rivers and creeks. Um, you know, what's the role of those FEMA flood maps and decision making right now? I mean, is there any way of sort of upscaling the flood maps in your opinion?
Well, they are eventually going to update this data. It's they called it what, Atlas 14, I think, um, that is 20 years old. And Atlas 15 was supposed to be out by now, but it delayed. It's because the U.S. government never does anything on time. So it may be within a couple of years that Atlas 15 comes out and you'll get more reliable, more realistic data. But what's going to happen when that data comes out? The insurance industry is going to take note of that, and they're going to pass on that information to their customers. And insurance rates, I think, are going to be going up in a lot of places by tremendous amounts by the end of this decade. Um, and you see what's happening in Florida right now. People are seeing double, triple their insurance rates because of those hurricanes that have hit and are likely to continue to hit. 2024 is going to be a horrible hurricane season. The ocean being at record warmth and going into a La Nina. That's like the worst of all worlds. And the insurance industry has to get ahead of it or else they go out of business. And so the insurance rates are going to skyrocket once the new data comes in.
Interesting. I mean, I have a question. I mean, just given your current, you're working at a consulting company now that designs infrastructure. Do you have a rule of thumb, to sort of, if you're designing a piece of infrastructure now that has a useful life of what, 50 years, 60 years, the regulations are probably looking retrospectively at this data that we know needs to be updated. To those, I mean, we have a lot of practicing engineers who join this session. I mean, what do you have a rule of thumb on design or planning for future infrastructure, maybe to help insulate also against some of those spikes in insurance that you might expect?
Yeah, well, it's always comes down to cost benefit analysis. If you want to be safe from flooding at the coast, the best way to do that is to move away from the coast. If you want to stay at the coast, best thing is to build higher. This is what they're doing in Miami Beach. They're basically raising every road in the whole city. So individual companies and individual communities are going to have to team up with these engineering companies, environmental engineering companies like AKRF and others, to try to plan for these things and to try to balance the need for protection with the cost. And that's where their expertise comes in, because we're never going to be able to plan for the worst storm of the rest of the century. That's not practical. So there's at some point where there's going to be a balance between the preparing or adapting and the cost, because the cost will be,
well, I'm just wondering if
drive
that,
out of business if you try to go too high.
I'm just wondering if that, that observation suggests that the approach to specifically floods has just got to change, right? I mean, there are these different themes in sort of flood preparedness, like a resistance approach, just like building a big wall to keep the water out versus this sort of accommodation approach that's sort of like acknowledging the fact that the future will be wetter and designing infrastructure in places so that they can get wet.
Right.
And actually that ties into a question that Carl asked, which is kind of interesting. He's asking if this increased wetness that we're seeing has any kind of, like, can you track it by ecological spaces? I mean, are you seeing more wetlands? Are you seeing broader floodplains in places where obviously urbanization isn't constraining, how far a floodplain, but is there sort of an accompanying ecological set of transitions that you're seeing over the last few decades?
Well, I'm finally seeing some businesses and communities realize that um, they don't want to move and they don't want to keep getting flooded. And so they try to find ways to let as much of the water get absorbed and not hit their structures as possible. You've seen that in New York City also, where they have made parks out of areas that would be flooded. And so when the flood comes, the softball field gets flooded and not Fred's house. So that's a way to adapt to the changing climate by changing the structure, changing the architecture, changing the landscaping of the area. And that is an increased business because people don't want to give up and move out. They're not going to shut down Atlantic City or Cape May or the Hamptons. They're not going to leave. You got to adapt to that, the changes that are coming.
Yeah. Well, this has been really, really helpful. I'm not seeing any more. Oh, we did get another comment by Ray about the Community Collaborative Rain, Hail, and Snow Network, a nonprofit of volunteers that gather precipitation data. So not sure if you're familiar with that, but that's real interesting. And right as we ran out of questions, now I'm getting a lot of questions. Ruben David is just thanking you for your many years of meteorological weather service and reporting, and thanking you for for this talk and your bow tie. And I wonder if you want to just I know something about that bow tie. I know bow ties are your sort of trademark, but that particular colored bow tie, do you want to just
Right.
tell folks what it represents?
Yes, this is known as the global warming stripes. The whole idea was developed by a climate scientist named Ed Hawkins. And we see this all over the world now. And there's even a day, it's called Show Your Stripes Day. And this is catching on all over the world, where we're talking about going back to 1850. This would actually be on the backside where it's really blue, which shows the coldness. And then it transforms into the warmer colors, showing the current. And the pictures are the best way to communicate. And this was just a brilliant move by Ed Hawkins in showing this. We try all kind of ways to communicate in graphs and pictures, and Climate Central's done some really great stuff with that, where they can actually show you what your street will look like after, if the climate warms by 3 degrees, for example. I'll show you a picture of your street or the center of your city. Pictures. That's why I wanted to chase hurricanes at the Weather Channel instead of just showing weather maps. But these stripes can be made for virtually any city in the world. And it'll be different for each city, but the trend will be the same, starting off cold and ending up warmer. And it's not a uniform thing. It doesn't warm up every single year. And that's part of the difficulty of communicating the dangers that we have facing us in the future. Look, there are a lot of people who enjoy these 60-degree days in the middle of winter, but the price that we're going to pay for that comes later.
Yeah. Well, I just want to thank you again for a great talk, and thanks so much for entertaining all these questions that have been sort of far-reaching in terms of their scope. So thanks for the great work. Thanks for your career and for all this inspirational work that you're doing now, talking about this really important issue.
Yeah, one of the top climate scientists in the world, Catherine Hayhoe, she gets asked, "What's the best thing that I can do to fight this issue?" And she says, "Talk about it. That's the best thing to do. Talk about it. Spread the word."
Right. And that's what we're trying to do. So thanks again, Glenn. And to all of you, please come back at the beginning of May. We'll have a focus on some solutions. We'll be having presentations by some community-based organizations that are collaborating with researchers on efforts to address the climate crisis, and that'll be the next CC Run seminar at the beginning of May. So with that, everybody stay dry. Glenn, thanks again,
All
and
right.
see you all next month.
Thank you.